Did you know corrosion eats up billions of dollars worth of pipelines, ships, and bridges, like a silent monster munching on our infrastructure every year? Silently being eaten away by something as simple as oxygen and water. But what if we could stop rust in its tracks? Not with paint, not with coating, but by redirecting electricity. Yes, there's a superhero in town called Cathodic Protection that stops this rust in its tracks. Today, we're diving into what cathodic protection is, how it works in technical terms, how it's set up in the field, and the cool ways we monitor it remotely. Stick with me. This is engineering with a spark. At its core, cathodic protection, CP, is a corrosion control technique. So, what's cathodic protection? In simple terms, it's a technique to stop metal, like steel pipelines or ship hulls, from corroding. Corrosion happens when metal reacts with its environment, like oxygen or water, losing electrons and turning into rust. Cathodic protection fights back by making the metal, the main structure, a cathode, in an electrochemical cell-like environment, protecting it from losing those electrons. Technically, it works by supplying electrons to the metal structure to counteract the corrosion process. Think of it like giving your pipeline a shield of extra electrons so it's too full to rust. Corrosion of metal, especially iron, typically occurs through an electrochemical reaction in the presence of water and oxygen. See the chemical equation on the screen on anode. Here, ferrous atoms lose electrons and become ferrous ions. This is the oxidation half reaction and occurs at the anode. Now see the chemical equation on the screen on cathode. Oxygen from air gets reduced by gaining electrons, forming either water in acidic conditions or hydroxide ions in neutral basic conditions. Now see how the formation of rust takes place as ferrous hydroxides. Ferrous ions react with hydroxide ions to form ferrous hydroxide. Further, this ferrous hydroxide is further oxidized to ferric hydroxide. Ferric hydroxide dehydrates over time to form rust, a hydrated ferric oxide. The basic idea is to make the metal structure like a cathode, which we want to protect, and another sacrificial metal is made anode, thus forming an electrochemical cell. This way, the sacrificial metal corrodes instead of corroding the main structure. This method works by reversing the natural electrochemical reaction that causes corrosion. This is achieved through two ways. 1. Galvanic sacrificial anode. A more reactive metal, like zinc or magnesium, is connected to the structure. It corrodes instead, sacrificing itself, like a loyal friend taking a hit for you. Instead of ferrous oxidizing, we force another metal to oxidize like zinc, magnesium, or aluminum. See this equation. These electrons are gained by the ferrous structure and protected from oxidation, so the protected structure becomes the cathode, hence the name cathodic protection. The environment. Soil or water acts like electrolytes. This system forms a kind of electrochemical cell. Impressed current. A power source, like a rectifier, pushes electrons into the structure through an inert anode, like graphite or titanium. It's like plugging your pipeline into a rust-proof battery. Let's get nerdy for a sec. How does this electron magic happen? Corrosion is an electrochemical reaction where the metal acts as an anode, losing electrons to an electrolyte, like soil or seawater. In today's digital age, CP systems aren't just installed and forgotten. They're monitored 24/7, sometimes from halfway across the world. Remote monitoring tools, CP data loggers. This records periodic data recording at test points, which later can be offloaded to mobile or laptop for further diagnosis. Wireless RMUs, remote monitoring units. It uses IoT devices which further send monitoring data to cloud server via GSM mobile, satellite network. This IoT device monitors voltage, current, and potential. SCADA integration. Remotely collected data may be interfaced with SCADA systems to represent an enterprise-level solution of pipelines and critical infrastructure, and real-time alerts for system failure or sabotage can be triggered. AI-based predictive maintenance. Historical data patterns over a time period develop a kind of predictive events, which helps maintenance practices to carry out. These technologies help ensure your CP system is always active, without needing manual inspections every day. This isn't just for oil giants. CP is used by municipalities for water pipelines, the aviation industry for fuel tanks, the maritime industry for ships and harbors, and the power industry for transmission towers. Without CP, corrosion could mean environmental disasters, billion-dollar losses, or worse, human casualties. So next time you see a pipeline, a ship, or even a rebar sticking out of concrete, remember, corrosion is real, and cathodic protection is the science that fights it. Thanks for watching. If you found this video helpful, please hit like, subscribe, and share it with your fellow engineers, students, and industry pros.